Welcome to the Trinix classroom. I'm Miss Nixon, and today's topic is long division with two-digit divisors. As with any long division problem, when working with two-digit divisors, we follow the same 4 steps. We first determine whether the first 2 digits in the dividend are divisible by the divisor. Because 84 is larger than 39, we can begin dividing here. We will explore our 39 times tables to see which multiple comes closest to 84. 78 is the closest multiple to 84 without going over. We know that if 39 times 2 equals 78, then 78 divided by 39 equals 2. So we will put our 2 on our answer line and move on to the next step. Next, we will multiply 39 times 2. The answer is 78, which we put below the line and move on to the next step. Our next step is to subtract 78 from 84. With 4 being a smaller number than 8, we will need to borrow. Taking 1 from 8 and regrouping it to the tens place, we are now able to subtract 8 from 14, which gives us 6, and 7 from 7 gives us 0. We can now move on to the next step. Now, we will bring down the next digit in our divisor and reset our steps. Once again, we will explore our 39 times tables to determine how many times 62 can be divided by 39. 39 is the closest multiple to 62 without going over. Since 39 times 1 equals 39, then 39 can go into 62 only once. We place 1 above the answer line and move on to the next step. Next, we multiply 39 times the 1 we just put on the answer line. 39 times 1 gives us 39. We put that below the line and move on to the next step. Our next step is to subtract 39 from 62. We will need to borrow. Once we have borrowed 1 from 6, we will subtract 9 from 12 to give us 3, and 3 from 5 gives us 2. 23 is lower than 39, and so it cannot be divided. It becomes our remainder. Our final quotient is 21, remainder 23. Let's try another. In dividing 9,763 by 45, we need to determine if the first 2 digits of the dividend are divisible by 45. Because 97 is greater than 45, we can begin dividing here. We will explore our 45 times tables for the multiple that comes closest to 97. 45 times 2 equals 90. This means that 45 can go into 97 twice. We place 2 above our answer line and move on to the next step. Our next step is to multiply 45 by the 2 we just placed above the line. 45 times 2 gives us 90. We place 90 below the line and move on to the next step. Next, we will subtract 90 from 97. 7 minus 0 equals 7, and 9 minus 9 equals 0. Now, we bring down the next digit in our divisor and begin our steps all over again. We will explore our 45 times tables to determine how many times 76 can be divided by 45. Because 45 is the closest multiple to 76 without going over, we can determine that 45 can go into 76 only once. We place our 1 above the line and move on to the next step. Next, we will multiply 45 times the 1 we just placed above the line. 45 times 1 equals 45. We place our answer below the line and move on to the next step. The next step is to subtract 45 from 76. 6 minus 5 equals 1. 7 minus 4 equals 3. Moving on to the next step, we bring down the final digit we will be working with in our dividend and reset our steps. We now need to determine how many times 313 can be divided by 45. Using our 45 times tables, we search for the multiple that comes closest without going over. The closest multiple, which is less than 313, is 270. Because 45 times 6 equals 270, we know that 45 can go into 313 6 times. We place 6 above the line and move on to the next step. Our next step is to multiply 45 times the 6 we just put above the line. 45 times 6 equals 270. Next, we subtract 270 from 313. 3 minus 0 equals 3. We will need to borrow 1 from 3. 11 minus 7 equals 4, and 2 minus 2 equals 0. Because 43 is less than 45, it cannot be divided, and we have no more digits in our dividend to bring down. 43 becomes our remainder. Our final quotient is 216, remainder 43. That is it for today. If you are challenged with long division, browse this channel for earlier videos which include division basics and simpler long division problems. Thank you for watching. Remember to subscribe to this channel for more videos.